Okay, good morning all. My name is Tim Towie at the Vermont Center for Geographic Information. And on behalf of the state of Vermont's Enterprise GIS Consortium, I'd like to welcome you all to our February 2023 Geo-Enlightenment session. The Geo-Enlightenment sessions where we invite others from the GIS world to give us a talk about latest, greatest, current things that have bearing on all of our work as GIS people. And with us today, we've got two folks from the USGS. We've got Steve Aichele and Sue Buto, both, again, of USGS, two different locations. Steve is currently in Pennsylvania, and Sue is out in Oregon. And they today are going to talk with us about the new 3D HP or 3D hydrography program that the USGS has in store for high resolution nationwide hydrography data. So I'll let them take it over from here. And just a note to everyone, this will be a presentation in two parts. Steve will go first, then Sue afterwards. They both welcome your comments and questions. Please use either the hand raise or the chat box or a combination thereof if you've got questions, and I'll be happy to take them. And just to let everyone know that we will record this session so that it will be available later for review at your leisure. So with that, Steve, I hand it over to you. Thanks for joining us.
All right, thanks, Tim. So as Tim mentioned, my name's Steve Aichele. I'm a geographer with the USGS National Geospatial Program and currently serving as the planning and management lead for the hydrography program. This year, we are transitioning from our legacy set of hydrography data sets, the NHD, the National Hydrography Data Set, the Watershed Boundary Data Set, and the NHD Plus High Resolution into the 3D hydrography program. And we're going to do over the next 20 or so minutes, give an overview of that. And then Sue Buto, who is our data acquisition lead, will speak a little bit about the data acquisition processes. So with that, we'll move on. There we go. So I like to start as many presentations as I can with this slide because it really sets the tone for, personally why I'm here, why the USGS National Geospatial Program exists, and really why we have all of these topographic maps going back over 100 years that we all know and love. And I'll also point out that some of them have been loved maybe a little bit too much. These paper maps have been the basis for land management, earth science, water resources work, and countless other things for 100 years. But a lot of that has been analog work. And frankly, we can do better. This is a little bit of a tricky slide to work through, so hang on. I'd like to start this slide on the right side, which is really the goal. And that's a three-dimensional replacement for the topographic maps. Topographic maps will always have a place, but with modern data, modern systems, we can really represent things represent the landscape, the subsurface, even I guess the supersurface, the atmosphere in 3 dimensions, and represent the fluxes and processes that interact across those thresholds. That's our long-term goal. That's that a 10-year goal, a 15-year goal. I don't know, but that's where we're going. And we'll switch over to the left side of the slide, talk a little bit about where we are. On the bottom left, you'll see the 3D elevation program. You're probably all very familiar with that. Looks like Vermont is filled in an old status graphic. And we're approaching 90% complete on data acquisition for that program. And that's really been a game changer in terms of how of surveying broadly, really. Above that, you see the National Hydrography Data Set Plus, the NHD Plus High Resolution. That similarly has demonstrated the value of catchments, the catchment concept to integrate networked hydrography with that elevation data of the landscape. So those two programs have been very successful. We've been working those over the last 6 or 7 years. But we need to, we're launching our next set of programs. first of those, and why we're here, is the 3D Hydrography Program. That's really leveraging that 3D elevation program data, that high resolution elevation data, to create better hydrography data. And then the second item there is the next generation of 3D elevation program. This is informed by our 3D Nation study, and we're just about to get that launched here probably next year.
Sam.
And so I mentioned the 3D elevation program really changed how we do things, or it really revolutionized surveys broadly. 100 years ago, 138 years ago, up until the mid 90s, we sent crews, surveyors, people, often in big hats with long beards, out into the field to gather data. They went out and they measured things, they collected data, and then they brought that data back and put it in an analog GIS, a map, and those maps were the basis for all those things we talked about. Starting in the 70s and really in the 80s and 90s, going gangbusters, we converted all of that analog geospatial data from those maps into digital data that we could analyze on a computer, right? But there's no new surveying involved there. It was all just transferring that old surveyed data. Now with 3DEP, we're really moving back into that original mode of collecting data and then rendering it in a variety of ways to make maps, but to also make derivative products. And so this change really represents the first systematic remapping of the nation's hydrography since we made the original topographic maps back in the middle of the last century. We have line work in some places in the NHD that dates back to the 40s. And that's challenging in a lot of ways. So this is a fairly big undertaking, really. But I think with 3DEP as a basis, we have the experience, we have the skill sets to do this. Oops. So again, a little bit of sort of where we are and where we're going. Where we are, many of you are probably familiar with the NHD. Vermont's had a very active hydrography stewardship over the years, and one of the first states to adopt really what we call local resolution hydrography. The NHD is the most current and comprehensive set of hydrography data out there. It's nationwide. It's at least 24K. It's better in many places. And we've been able to do that with the support of stewards. At one time or another, we've had stewardship agreements with 41 different states and DC. Unfortunately, part of that stewardship model is that people update sort of what they want when they want. And so national consistency has really decreased since the beginning. And so where we might have, we have, for instance, particularly good irrigation canals in Idaho. And I don't know that there might not be any canal features in Vermont. I don't know, but these things have been updated sort of various degrees of rigor over the years. And it makes it difficult to know sort of what you're getting in the NHD in a lot of ways. And then, of course, the NHD, much of that data is still derived spatially from those field surveys, which were fairly amazing back in the day, but don't align well with a 1 meter LiDAR product. So then we have an opportunity here to really leverage both the data and the experience from 3DEP to build a new hydrography program. First and foremost, we want to get data that aligns in 3 dimensions and 4th dimension time with that 3D elevation program data to replace that older variously sourced elevation data. We can also leverage some of our experience from 3DEP in terms of governance, broad area announcement and contracting, those things Sue will talk about, as well as setting specifications and validating data. And then, we want to build this system for hydrologic applications. We won't need to be able to make maps with it, but maps aren't the primary output of this. And so again, and then referencing back to the three-dimensional national topographic model, we really want to be able to account for processes and connections through the whole vertical slice. Again, a little back and forth where we are, where we're going. One of the challenges in hydrography is that it's sourced from the cartography, not just the line work is placed where it was surveyed, but anything that was kind of watery on those topographic maps found a place somewhere in the NHD, right? And so we have lots of different types of pipelines. These are a few of my favorites. We have 24 varieties of reservoirs. Reservoir means something to most people, but it probably doesn't mean a swimming pool. But we have swimming pools in the NHD. We have treatment ponds of various kinds. We have rapids, levees, kind of water adjacent features. And these things are all data that we carry around in the NHD. And they have to have rules and topological checks and all sorts of things that go along with carrying those feature types. This really creates a burden for maintenance for us and from a steward perspective, but it also creates a major barrier to use. And much of that is represented right here. Some of you have probably seen these before. Some of you might have been scarred by the experience. But the figure in the upper left is the National Hydrography Dataset data model. On the right, we have the WBD data model. Down below, we have the NHD plus high-res data model. And the purpose is not to be able to explain these things or memorize them from the slide, but just to give a little bit of a graphic representation of how much stuff has to happen to do these as three separate data sets, carrying about 250 different feature types altogether. And that requires about 13 different tools updated up there. And so, it's a lot of infrastructure, a lot of overhead to carry this data around. So a couple of our technical goals in 3DHP are really to radically simplify the data set, but also leverage that catchment concept that we demonstrated in the NHD Plus. I want to make them integral and part of the system from the beginning rather than something that was processed later. Similarly, we can use those catchments to build hydrologic units. So rather than deriving the WBD as kind of an independent data set and using that to enforce the catchments, we can use the elevation data to build the catchments and aggregate those to create hydrologic units. And then throughout this whole thing, really try to simplify and accelerate the workflow to speed maintenance. That all really begins with the data model. I showed you the three diagrams before. And those were state-of-the-art, cutting-edge stuff in 1995. We can do better now, and we're going to base this on the Open Geospatial Consortium's Water ML2 high features conceptual model, and this is something that's being adopted in NOAA for the Office of Water Prediction, their National Water Model. In Canada, we're interacting with both of those groups pretty frequently. And within the USGS. So we're all really speaking with a common vocabulary, maybe working with common features to do analysis. We're building data that then can flow directly into predictive or descriptive models. And then part of that is also to shift a lot of the attribution burden out of the data model itself and into addressed features. If you're familiar with events or linear referencing, that's really where a lot of the information about the features will reside in 3DHP. And given all of that, again, I want to underline the draft part, but this is what we're replacing these three graphics of 250 or so feature types. We can represent about 95% of the content of the NHD with this much simpler data model. And so that makes a lot of other processes a lot easier. And also, we'll speak in a moment here, but we want to make this easier for people to use so they can consume what they need, not get the whole data set dumped on them and have to figure it out. And that really starts with a couple, the sort of the way the data set's built. On the left are, the input section. This is where, this is the data. This is the source data. Many of you are probably familiar with elevation-derived hydrography, that concept. We are going to migrate the existing NHD high-res, the 24K or better data, into 3D HP as a sort of seed data set. And then we have the scaffolding concept, which really just explains how different systems connect, so that if we update the Huckate, for example, we know which upstream and downstream watersheds that needs to connect to. But all that is on the left side. That's all input data. We go through and that'll go through a validation step to ensure the quality of it. Then I'll go into a core database, which I actually just showed you that sort of draft data model. But we don't even want to dump all of that on users if that's not what they need. We really much prefer to have an abstraction that provides a set of that data that's optimized for cartographic purposes, a set of that data that's optimized for, built from the same pieces, but optimized for addressing and linear referencing. Water census is a big driver within the USGS, and then potentially other views. But having that abstraction layer really allows a lot more flexibility in terms of tools and data maintenance, in that we don't have to, in order to change, for instance, an F code or something internal to the database, we don't have to propagate tools and all sorts of changes out to the whole user community, as long as we can hit those same expectations for the views. And so that abstraction layer is actually a fairly big piece of the concept going forward. In terms of populating 3D HP, I mentioned we're going to migrate the 24K and HD into 3D HP. It's, most of that data is 2D data. It is going to have, some fairly limited functionality because of that. And again, much of it doesn't align particularly well to the elevation data. So that's, a little bit of a challenge, but it'll provide a common linear referencing framework that can continue going forward. And it'll put all the best available data currently in one data set. Moving forward, we want to add data from elevation-derived hydrography projects based on the specifications we published. And kind of as a key concept, we want to validate that data prior to putting it in the database. I mentioned there were a variety of sources for NHD, many of which, much of that still comes from the old 24K maps. But stewards have done a lot of updates over the years. Some of them have done very good updates. Some of them have done, hit or miss updates. A few of them actually kind of introduced some challenges. But we want, before data goes into the database, we want to make sure it's good and up to specification. And so that's kind of a key difference between, what we've done and what we're doing going forward. And that also makes some opportunities for improving maintenance in other ways. We've leaned on state editors pretty hard over the years, and expected a lot in terms of specialized software knowledge and training, and really a lot of GIS knowledge, even just basic IT knowledge in a lot of ways. In order to make updates in the role of a steward. We want to move away from that, in part by doing this validation up front. We expect there'll be a lot less editing required. We're not trying to make 50-year-old data fit new landscapes. We're starting with that new landscape and doing that data update up front. But we're also going to try to simplify that by using the markup tool that's been up for a number of years to harvest input from states for improvements to the data. You find something has a different flow regime. You find maybe this doesn't start flowing as far up as we've drawn it. Maybe this, I don't know, something attribution issues. Anyway, those markups can be submitted through a fairly lightweight interface that doesn't require a lot of specialized, GIS training. And then we'll make those edits centrally after a vetting cycle with state stewards who want to retain that role. But that'll be, I think, a much simpler process and really move that closer to that local hydrologic knowledge that we wanted to tap, and a little less of the geospatial expertise that was required before. In terms of data distribution, I mentioned the view concept. Initially, we're working towards these three, a cartographic mapping view, an addressing view to really support the Internet of Water, and then hydrologic units to support the water census. Another difference, rather than the NHD data model was too messy to serve effectively through a web service. We can do, web map services with it, but really a web feature service was pretty challenging. We think the new 3DHP system will be primarily a web service system, so that everyone can use the same version of the data. There'll be a lot less downloading the data, doctoring it up, and letting that live on your server, on your hard drive for the next 10 years. We do need to have actually annual static releases, and so these are referenceable. This is a big requirement of the research community that uses the data. They don't necessarily need to have up to the week or up to the month kind of updates, but they need to have a static version that they can say, I did this analysis with the 2025 version of 3DHP, and here's the DOI for that. I mentioned the Internet of Water. We are really trying to push for linear referencing as a core functionality of the data set, but we don't envision owning that data ourselves. This is data that you as users would own. If you want to attach your trout information or your water quality sites or stream gauges or whatever to the network, we encourage you to do that and share that data. And this is an effort we're making with the Internet of Water group from Lincoln Institute. This is also geoconnects, and that's to keep this data that has been trapped in flat files across the country for the last 100 years. Try to make it possible to share that effectively, so that a federal agency can see state data, state agency can see federal data, and as universities, who else, so that anybody can see that data and work with it effectively. This is similar to, for instance, the water quality portal, if you're familiar with that. So there are a lot of roles in this, and this looks a lot like the 3DEP chart as well. Much of what we're doing is sort of system maintenance, right? So we're organizing the governance. Sue particularly is going to be coordinating a lot of the partnerships, managing the specifications, handling the data management and validation portions. But we really do see roles across the country, across all the user groups, for a variety of things. And I want to point maybe particularly to that one in the lower right, way down in the lower right, but it's applications. And this is all a great idea, and everybody, this is all exciting, from a sort of techie side, but doing something with the data is where this really demonstrates value. A data set that isn't used isn't worth a lot, but being able to leverage this for meaningful applications is really why we're doing this. I put this chart up again. This is not necessarily a something you need to read and commit to memory, but to give an idea of what we have been doing, where we are outlined in that black box, and where we're going, and maybe highlight the point that out of the 20 odd rows there are only 2 that we aren't doing something on this year, which means they effectively, basically everybody's dancing as fast as they can on this. we're making this happen, but we do have a lot going on this year. We are dialing back, as I mentioned, the traditional hydrography programs, trying to launch 3D HP. And so, there are some transition challenges making that happen. But we expect to be, fully producing 3D HP data next year. So that's the transition we're making happen here. And with that, I'll throw this up for a couple seconds in case you want contact info. And then maybe field a couple questions while Sue takes control for her talk. I need to bring my window back up so I can see if there are questions.
Yeah, folks, feel free to chime in with the chat or raise your hand while we're waiting for Sue Buto to get our slideshow up and running. Steve,
Yes.
Hugate.
Yeah,
Go ahead,
hi,
Steve.
thank you. It's more of a comment than a question. I really appreciate how you seem to have decoupled the geometry from the attribution, because come from a LiDAR background, so I'm very interested in line placement, whether they're flow lines or watershed boundaries, and those being generated directly from the elevation data. But a hydrologist would be interested not only in that, but all the information that you were able to take all the complexity and reduce it and maintain 95% of the data. That's wonderful. So more just wanted to give you some props for the work you guys have already done, because it's a huge task.
Wait, thank you. And yeah, I think that data complexity was it was challenging for pretty much everyone involved. I don't know that I've ever talked to a user who said, yeah, we love having all of it. They want the piece they need, and typically throw away the rest of it. I see a question or a comment, I guess, from Valerie. And yes, absolutely, and that's part of the challenge, and actually something we're part of migrating away from kind of a stewardship of the willing kind of model to a more consistent data update process. We're trying to, again, make that more consistent process, include data validation within the flow, and move on from there. And with that, I'll pass it over to Sue to talk about data acquisition.
Thanks, Steve. And thank you all for the invitation to speak. Hopefully you can see my slides. Like Steve, I am a geographer with the National Geospatial Program with USGS, and I am the lead for hydrography data acquisition, which is sort of a new paradigm for hydrography. So we'll be on this journey together. So Steve mentioned sort of how we're moving forward with the 3D HP. So I want to step back a little bit and make note of the background of why we're doing this, beyond understanding that our hydrography data is too complex and it's dated and we need to move forward into a more modern system. We're not doing this sort of in a vacuum. In 2016, we conducted a hydrography requirements and benefits study, which is really the way we always start out these new program designs, is reaching out and asking the user community and the GIS community, how do you use our data and what do you need from our data? And so in the HRBS, we documented over 400 mission critical business uses across multiple sectors, federal, state, tribal, and national associations. And we found that the current data as it stands right now, the NHD and WBD in particular, provide over $500 million in annual benefits, and largely benefits in people not needing to do extra work to use data and having duplication of effort across the US for hydrography data mapping. But we also found that a modernized hydrography program, particularly data that is more spatially accurate and aligned with elevation data can provide over $1 billion in benefits. And that's if all our user requirements that were identified in the study are met. And so that's how we got to the place where we are now building the 3D hydrography program. And as Steve mentioned, we're following a lot of the lessons learned and a lot of the really good practices that were built through the 3DEP program. And those include establishing a governance structure to develop and coordinate partnerships and acquisition plans, and also to learn and grow around technical issues and concerns as well. And then adding 3DHP to our broad agency announcements, and I'll go into more details there. I think many of you are familiar with the 3DEP broad agency announcement. And then contracting for data acquisition, primarily through our USGS geospatial products and services contracts. And as Steve mentioned, you know, this is a shift of paradigm, rather than sort of using the coalition of the willing stewards to do most, if not all, of the editing and update of the data. Leveraging the private sector to help us in this partnership, we think will gain efficiencies in how we do this work. But then we'll also allow, much like the 3DEP program, for cooperative data acquisition, meaning providing grants for folks who want to manage the data acquisition themselves, and also take in contributed data. And the key to all this is providing specifications, as Steve mentioned, so that we have a bar that is set for the data coming into our database, and we're validating against that. So we know that the data that comes in is in good condition. So this is kind of a life cycle of, you know, many geospatial data sets, but particularly focused on the 3DHP, running from planning through data acquisition and all the way down to data access. And my role kind of sits in the planning and the data acquisition side of this effort, and focused on partnerships and acquiring the data, when then it gets passed on to our data validation and out through the process to publication to the nation. And all this requires coordination. It's a great deal of coordination at many levels and across, you know, as many sectors as we can reach. And the effort is to really align goals with each other and identify common requirements and find areas of overlap where people need data. And one of the main goals is to eliminate duplicated effort. Duplicated effort is a waste of everybody's time and effort, money. So we want to avoid that where at all possible. And that involves really pooling our resources to get this done. So I'll start with federal governance. We do have a 3DHP working group, which is a multi-agency federal coordination body. And our member agencies are working to move forward together with a common purpose around hydrography data acquisition, with a goal to improve the currency and accuracy of hydrography mapping to meet federal mission requirements. So one of the main goals is to develop acquisition strategies at the federal level, and maximize funding, again, at the federal level to support those goals. And this is actually part of an envisioned 3D national topography model joint governance, as Steve described the 3D NTM, that would support our overall goal that we share with NOAA in particular, to build a 3D nation, which is a continuous elevation surface for the nation and integrated hydrography. So then there's state coordination, which is really key and very important to us, coordinating with our state stakeholders. We do that in a few ways. One is through collaboration with the National States Geographic Information Council, or NSGIC, and that helps us to coordinate and engage with primarily state GIOs, but other key stakeholders who are involved in NSGIC. And in fact, we have a NSGIC forum today where our colleague Dave Blodgett will be talking about the data model. And then, as I'm sure many of you are familiar, we have a network of national map liaisons who lead outreach and coordinate for 3DEP and 3DHP in their respective states and regions. And I'm sure many of you are familiar with Dan Walters and Luke Sturdivant, who served in Vermont. And all this works to help us keep our key stakeholders informed and align our acquisition goals between our federal and our non-federal partners. And again, here's our user engagement map. Yeah, user engagement is really key to us because they're people who sort of help have boots on the ground in the state, in their states and regions, and really do work hard to develop relationships and understand what each state needs, particularly around data acquisition at the national scale. So it's very helpful. If you don't have context with user engagement, you can get them at the URL below. So and then we're moving into, this is part of the work we are doing with NSGIC, is to build state acquisition strategies. And that is developing a set of plans and best practices for coordination at the state level, identifying business uses, identifying funding partners and strategies, and sort of putting together best practices for acquiring geospatial data that feeds into the national programs in your state. And we also provide forums to help our partners learn and grow through collaboration. And as I mentioned, we have a forum today with NSGIC. So all this rolls up into what turns into an annual data acquisition plan. And it is built on partners, sort of in this sort of continuum of data acquisition. On one side is our federal working group, where our federal partners identify their mapping priorities, and we can enter directly into interagency agreements with our federal partners. And those funds can be used either as matching funds on broad agency and announcement applications, or for direct acquisition through our GIPSY process. And then there's movement towards developing a broad agency announcement for 3DHP, as I mentioned. And the broad agency announcement is a fair and equitable process that allows us to partner with state and local non-federal entities. And so the two of these come together to develop our annual acquisition plans. So a little bit more about the broad agency announcement for anybody not familiar, although I know Vermont recently applied for a new update to your existing 3DEP data through the BAA. For those of you not aware, the BAA is, again, our mechanism that we use to partner with non-federal entities, and it's designed to be a fair and equitable process. So proposals are put into the BAA and then evaluated against a set of criteria, so that we make sure that we're choosing projects not through favoritism, but through merit on the proposal, the proposed area that for data acquisition. The BAA can be applied for by federal agencies, by state and local governments, by tribal entities, academic institutions, and the private sector. And applicants are encouraged to build funding coalitions and pool resources to fund 50% or more of project costs for the BAA. And then federal matching funds are added to cover additional costs. And in 3DHP, there'll be a little bit of an extra challenge in that we will be collecting not to state boundaries or political boundaries, county boundaries, but to hydrologic unit boundaries. So there'll be an additional challenge of building, in some cases, multi-state funding coalitions where those hydrologic units cross state boundaries. And so back again to our annual data acquisition plan. We are working on a 3D HP BAA. We anticipate that we will release a BAA in FY24. Some of that is dependent on federal budget, but that's our expectation. So keep an eye out for that. If you have folks that are interested in applying to the BAA for 3D HP acquisition. And then our acquisition mechanisms, we mentioned a couple times our USGS geospatial products and services contracts. GIPSY is a multiple award acquisition vehicle that's managed by the USGS. And the firms that are on the contract are selected based on their qualifications for doing the work that is asked of them. And we use GIPSY for LiDAR acquisition, but also for hydrography, which is an emerging process for the GIPSY contract, and also for geophysical and imagery acquisition, all sorts of geospatial data acquisitions. One of the key things about using GIPSY or any data acquisition that goes through the BAA, if it's whether it be a GIPSY contract or your own contract that is partially funded by USGS through the BAA, all the data goes through data validation to ensure that it conforms to our specifications. So it's a GIPSY and these other processes are an efficient way for us to ensure that the data come through those validation processes and we can be ensured of the quality as they go into the database. So this is a repeat of Steve's roles slide. But I do want to highlight sort of the places that data acquisition lives, which is in this governance and partnerships area, and where USGS and our federal and our state partners come together to form a community with the private sector really sort of being most responsible for the actual data acquisition so that we cross sectors and leverage the power of those of everybody's abilities. And so probably it's clear to you that we look at 3D HP as a community investment. And this is somewhat new, as mentioned, to the hydrography system. We've sort of relied on that volunteer army to some degree in the past. And now we're moving into a system where there's a upfront data acquisition investment that's required. And then we believe and we are pretty sure that going forward, that investment becomes less because the data is of good quality and requires much less intervention by folks on the ground. So we do estimate that the costs, if we spread the costs across 9 years for our stakeholder investment, updating our national hydrography data is estimated to be about $685 million investment from the community. And this all goes to feed, as Steve mentioned, the 3D national topography model. And again, the real vision for the 3D NTM is to build a continuous data surface that covers the nation and not only provides foundational data that's critical to current initiatives, but we believe that this initiative also will enable new and emerging applications that we've not really envisioned before. So we're very much looking forward to working with you and building our vision for the 3D national topography model. And with that, I will leave this up for a second and take any questions for myself or for Steve.
Thanks, Sue. Thanks, Steve. Super helpful covering both the technical side as well as the people side of things that will take to get this up and running. So at least personally, and for us on behalf of VCGI, I think that has helped clarify some of our questions. So if folks would like comment, questions, please chime in and we'll field them from here. So Steve.
Hi, Sue. Thank you so much for your work on this stuff.